1.3 Quadratic Functions. On slide 2, you see the same table that we've been talking about for some time as far as the different types of quadratic functions. Once again, this is looking at standard form, intercept form, as well as vertex form. On the right-hand side, once again, we're going over the easiest things for you to be able to solve for within each one of these forms. Notice, standard form, easiest to start with would be the y-intercept because we are inserting x being 0. So if x is equal to 0, notice this would turn into 0, this would turn into 0, and we are left with c, so 0, c. In the case for intercept form, easiest would be x-intercepts because we are then turning the entire equation equal to 0, and we are solving for our x, our q, and our p. Last would be the vertex form. In this case, we're just taking a look at h and k, solving for h and k, and moving from that point. On slide 3, here we have the definition of a quadratic function. It is ax squared plus bx plus c. Each one of these variables describes a different item. For example, a, b, and c all represent different coefficients within the problem. The x is the variable of the problem itself. Now, none of these different terms are going to be the same, as you can see, but it's very important to note that a will never be 0. In slide 4, here we're talking about the different aspects of our standard form. So notice, if a is positive, the parabola is going to open up. If a is negative, the parabola is going to open downward. In the vertex of the graph, how are we solving for that vertex? We're going to use this equation right here of negative b over 2a. Now, as we figure out what negative b over 2a, that's going to give us our x. So, our vertex would be equal to negative b over 2a, and we're going to get the f of x of negative b over 2a as our y. So once we get our vertex or our x, we're going to go ahead, plug it into our equation, and once we do, that would then give us our y. Keep in mind, this negative b over 2a is the same as our axis of symmetry. In slide 5, we go ahead and we start determining whether our equation or our parabola as a whole would be a positive, a negative, meaning is it going to face up, is it going to face down, and whether it would have a maximum or a minimum. So this would be done by taking a look at our a, or our first term. In this case, we look for the highest exponent. So let's first do that. We identify the largest exponent, which is going to be 8x squared. In our second equation, it would be negative 7x squared. Notice whether it's positive or negative, and the coefficient that's there does not matter. We are looking for the largest exponent. There are times, like in the third example, where it would not be in standard form or it will not be in order. And in our last example, x squared would be our largest exponent. In order for us to determine whether it's going to be up or down as far as our parabola, we need to take a look at our coefficient and determine whether it's positive or negative. The fact that 8 is positive means that it's going to face upward. Negative 7 would be down, negative 3x squared would be down, and x squared would be up. That would mean that, once again from the beginning, we need to determine our minimum or maximum. Now, we aren't having to find a numeric value behind it, but we are just saying whether it's going to have a minimum or maximum. This would be a minimum, maximum, maximum, minimum. Remember, it will continue to go up or continue to go down. So in our first example, you can see that there would be a stopping point at the minimum number that it could be, but as it goes upwards, there is no stopping it. If we're looking at example 2, notice it continues to exceed downward, but there is a stop at the maximum point that it can reach. Let's take a look at slide 6. In this slide, we are talking about finding the line of symmetry. Now, this is the same equation that we were using before of negative b over 2a. We go ahead and look at the example on the right-hand side. In this case, notice a negative 18 is our b, so a negative of our negative 18 would give us a positive 18. Times 2 times 3, which is 6. 18 divided by 6 is 3. Now, we did find the x portion of our vertex, or our axis of symmetry, which would be 3. But we would still have to go ahead and continue if you are trying to find the entire vertex. In this case, we're only finding the line of symmetry, which would be 3. In slide 7, we're finding the entire vertex. Now, with this problem, we go ahead and see that our negative b over 2a is going to be a negative 8 over 2 times negative 2. Negative 8 over negative 4 is a positive 2. So we determined the x value of our problem. Now it's to find the y. Notice, once we find our x, we go ahead, we plug it back into our equation, and we solve. In this case, we go ahead, plug in 2. 2 squared is 4. 4 times negative 2 is negative 8. 8 times 2 is 16, minus 3. So negative 8 plus 16 is positive 8, minus 3 is 5. Our answer here for the vertex would be 2, 5. In example, in slide 8, we go ahead and we take a look at graphing a quadratic that is in standard form. Generally, we want to find our line of symmetry. From there, find our vertex. And then we want to find as many points as possible that would allow us to draw our graph as proper as possible. So we begin with our line or our axis of symmetry. We go ahead, find our axis of symmetry, which would be negative 4 over 2 times 1. Negative 4 divided by 2 is negative 2. We go ahead and plug in our value in. 2 squared would give us 4 plus 4 times negative 2 minus 5. 4 minus 8 minus 5. 4 minus 8 is going to give us a negative 4. A negative 4 minus 5. Add our opposite. This will lead into negative 9. In this case, our first answer for our vertex would be negative 2, negative 9. Axis of symmetry would be x is equal to negative 2. In this case, we know that this would be a minimum style problem because we have a being a positive. Let's go ahead and graph our vertex, negative 2, negative 9. From there, we go ahead and figure out our x-intercepts. We try to see if our equation will factor out. In this case, this equation will factor to be x plus 5, x minus 1. This would leave us with x plus 5 equals 0. X is equal to negative 5, which means negative 5, 0 would be our first point. X minus 1 is equal to 0. X is equal to 1. 1, 0 would be our other point. We go ahead, find our y-intercept. Our y-intercept is whenever x is equal to 0, which means this would be 0, negative 5. We're going to go ahead, draw that out, 0, negative 5. Keep in mind our axis of symmetry be along this line right here. Find the reflection of our y-intercept and graph the equation. As a whole. As you can see, on the left-hand side, remember we read increasing and decreasing from left to right. We are decreasing from left to right and increasing on the right-hand side. So increasing would be from negative 2 to positive infinity. Negative infinity to negative 2 would be decreasing. Our domain is always negative infinity to positive infinity. Our range goes from the lowest point, which would be at negative 9, and increases. Remember, we are allowed to use a bracket for the range and domain if need be. Our end behavior, notice since it's facing up, as x approaches infinity, f of x approaches positive infinity. As x approaches negative infinity, f of x approaches positive infinity. In slide 10, we go ahead and do the same thing. We start off with our axis of symmetry. Here we're going to go ahead, negative b over 2a, so negative 6 over 2, which is going to leave us with a negative 3. We go ahead and plug in our equation. Negative 3 squared is 9, plus 6 times negative 3, which is a negative 18, plus 2. 9 minus 18 is a negative 9, plus 2 is a negative 7. Our vertex in this case is going to be -3, -7. Axis of symmetry would be -3. Take a look at our A. Because it's positive, we know that it would be a minimum. Our x-intercept, we take a look at the equation and try to factor. In this case, general factoring will not work, but there are other options that we could use. We can either use completing the square or the quadratic equation. Let's go ahead and graph our vertex, -3, -7. Now, knowing that this is going to face upward and knowing the position of the vertex, we know that we're going to come up with two answers as our x-intercepts. Let's go ahead and take a look at the y-intercept. The y-intercept is whenever we solve x to be 0. In this case, it would be 0, 2. We go ahead to the reflection of 0, 2. From here, we are actually able to do the rest of the problem, and we can leave the x-intercept for the last part. From here, we are able to see just where our lines would match up. As you can see, it is decreasing as we move left to right, and it increases after the axis of symmetry. Notice at -3 is our axis of symmetry, which means it is going to decrease from -infinity to -3, and -3 to positive infinity, it is increasing. Our domain is from -infinity to positive infinity. Our range is from -7 to positive infinity. Our end behavior would be as x approaches infinity, f of x approaches positive infinity. As x approaches -infinity, f of x approaches positive infinity. Now let's go into the x-intercept. The x-intercept is going to take a little bit more to solve because we're going to use completing the square and we're going to use quadratic equation. I'm going to show you both methods so that you're able to make an informed decision on whichever process you would like to take. Both of them will give you the correct answers. So let's go ahead. Let's first write out our equation. X squared plus 6x plus 2. We'll start off with completing the square. For completing the square, we start off with our equation, and we are going to want to move the 2 to the right-hand side. The reason for that is because we know that the left side equation currently is not a perfect square, because we can always take a look at our b, and when we square it, that's going to give us, or when we divide by 2 and square it, it's going to then give us the ability to see if it's a perfect square or not. In this case, 6 divided by 2 is 3. 3 squared would be 9. So notice in this case, 2 would not give us a proper square. So we go ahead, x squared plus 6x is equal to negative 2. I'll go ahead and write down the equation for you just in case. B over 2 squared. From there, we need to find that number that's going to give us that perfect square. So we go ahead, use our equation, b divided by 2. 6 divided by 2 is 3. 3 squared would be 9. Whatever we do to one side, if we add 9 to one side, we add 9 to the other. Once we've done that, we go ahead and factor out the left side. This would give us x plus 3 is equal to 7. We simplified x plus 3 squared is equal to 7. We're going to want to get the square root of both sides. This would leave us with x plus 3 is equal to positive or negative square root of 7. And we're going to subtract 3 from both sides. This would leave us with x is equal to negative 3 plus or minus the square root of 7. Keep in mind, because it's an x-intercept, our answer would be negative 3 plus or minus the square root of 7, comma, 0. Or you can write it separate as negative 3 plus the square root of 7, comma, 0, and negative 3 minus the square root of 7, comma, 0. Our other method would be using the quadratic equation. We first start off with our equation, which would be negative b plus or minus the square root of b squared minus 4ac all over 2a. We go ahead and plug in the numbers. So that would be negative 6 plus or minus the square root of b squared would be 36 minus 4 times 1 times 2 all over 2. We simplify this a little further. Negative 6 plus or minus the square root of 36 minus 8 over 2. Negative 6 plus or minus square root of 28 over 2. We're going to go ahead and simplify the square root of 28. This simplifies and breaks down into the square root of 4 times 7. 4 will come to the outside, which means this would be 2 square root of 7, and that would be a plus or minus. So negative 6 plus or minus 2 square root of 7 over 2. Now, something to keep in mind is that we cannot divide by 2 on the inside of that square root, only what is on the outside. So in this case, it would be negative 6 over 2 plus or minus 2 square root of 7 over 2, which would give us negative 3 plus or minus square root of 7 as an answer. Keep in mind, what actually occurs here is that for our x-intercept, this would be negative 3 plus or minus the square root of 7, comma 0. Or it could be rewritten as negative 3 plus the square root of 7, comma 0, and negative 3 minus the square root of 7, comma 0. Both methods work perfectly fine in order to find your final answer. Go ahead, write our answer. So that would be negative 3 plus or minus the square root of 7, comma 0. Slide 11. We go ahead, do the same thing. Start off with our axis of symmetry. Notice this would be negative b, or 6 over 2a, which would be negative 2. This would be negative 3. We go ahead and plug in a negative of a negative 3 squared minus 6 times negative 3 minus 3. Negative 3 squared is 9 times negative 1 is a negative 9 plus 18 minus 3. Negative 9 plus 18 is a positive 9 minus 3 is 6. So our vertex here will be negative 3, comma 6. Axis of symmetry is negative 3. We know that there's a negative in the A, which means this would be a maximum. Now in this case, we know that we're not going to be able to break down and factor that equation, so we're going to go ahead and skip straight to our y-intercept. Our y-intercept here would be 0, negative 3. Draw out our vertex, negative 3, 6. So we're going to go downward. Our y-intercept is 0, negative 3. This would give us a rough view of how this parabola is going to look. We can see from left to right, it is increasing, and it begins to decrease on the right side of that axis of symmetry. Axis of symmetry is negative 3, so when we write our increasing and decreasing, we keep that in mind for our numbers. Increasing would be from negative infinity to negative 3, and from negative 3 to positive infinity, it would be decreasing. Our domain is from negative infinity to positive infinity. Our range is from negative infinity up to 6. Keep in mind, we are always going from least to greatest, whether it is facing up or down. Our end behavior is that as x approaches infinity, f of x approaches negative infinity. Keep in mind, we are talking about the y when we're talking about f of x. So we're saying as our x moves towards infinity, meaning moves to the right, the y continues to go towards negative infinity. As x approaches negative infinity, meaning as we move further left, we can see that f of x, or our y, would continue to move down or towards negative infinity. We go ahead and work our problem the exact same way. Now you have a choice of completing the square or quadratic equation, whichever one you prefer. For this equation, I'll show you how to do it with completing the square. So we begin with our equation, negative x squared minus 6x minus 3. Now, generally, we do not want to have an equation that has a negative in the front. Whenever that does occur, we want to go ahead and we want to divide that entire equation by -1. So, negative x squared minus 6x minus 3 is equal to 0. We're going to divide both sides by -1. Remember, 0 divided by anything would be that same 0. So here we have x squared plus 6x plus 3 is equal to 0. Because we know that 3 is not a perfect square, we go ahead, take a look at our b. Negative b divided by 2 squared would be our equation. Negative 6 divided by 2 is 3. 3 squared would give us 9. Sorry, negative 6 divided by 2 is -3. That negative will be taken care of once we square the -3, which would be still a positive 9. Before we do that, we're going to move over the 3. X squared plus 6x is equal to -3. We run our equation. We end up with positive 9. Factor out the left side. X plus 3, x plus 3 is equal to 6. X plus 3 squared is equal to 6. We get the square root of both sides. This would leave us with x plus 3 is equal to positive or negative square root of 6. Subtract 3 from both sides. X is equal to -3 plus or minus the square root of 6. Now, our x-intercept in this case would be -3 plus or minus the square root of 6, comma, 0. Go ahead and insert that into our answer. -3 plus or minus the square root of 6, comma, 0, and go from there. Let's take a look at slide 12. So, begin with our axis of symmetry. -6, or a negative of a -6, divided by 2 times 1. 6 divided by 2 is 3. We go ahead and plug it back in. 3 squared is 9. Minus 6 times 3 is 18. Minus 11. 9 minus 18 is a -9 minus 11. That would leave you with -20 once we subtract 11. Our vertex here would be 3, -20. We go ahead, mark down our axis of symmetry. X is equal to 3. In this case, This would be a minimum. Our y-intercept would be 0, -11. Now, in this case, what ends up happening is the graph itself is too small for the graph that we are actually working on. But we are able to go ahead and have an idea of what is going on. For example, if we know that it's a minimum, and we know that we are dealing with a positive parabola, no matter the point, it's going to look just like this. Our vertex would be at 3, -20, and most importantly, we know that the axis of symmetry is 3. So we go ahead and notice that it is going to decrease on the left-hand side, and it's going to increase on the right-hand side. So increasing would go from 3 to infinity. Decreasing would go from -infinity to 3. Our domain would be from -infinity to +infinity. Our range would be the -20. So it would go from -20 to a +infinity. Our end behavior, since it's facing upwards, as x approaches infinity, f of x approaches +infinity. As x approaches -infinity, our f of x is going to point the same direction at +infinity. We go ahead and complete the x-intercept. Now in this case, I'm going to show you the quadratic equation. So remember, our equation here is going to be -b plus or minus the square root of b squared minus 4ac all over 2a. Our equation is x squared minus 6x minus 11. This would be 6 plus or minus 36 minus 4 times 1 times -11. All underneath the square root over 2. Here we have 6 plus or minus the square root of 36 plus 44 over 2. 6 plus or minus the square root of 80 over 2. We're going to have to break down that 80. Now, there are times where we may think a number is going to be best used in a certain way or another. So what will happen is we go ahead and start breaking down that 80. Now, there are times where we think a number works out, but there's a better number. You do have to realize that when we are breaking down a number such as 80, we have to look at all the possibilities. Now, if initially you choose a number that's on the lower side, for example, 4 times 20. Once we get the square root of that 4, we're going to end up with 2 square root of 20. But the 20 can also break down into 4 times 5. What would happen is that as we take that 4 from the outside, from the inside of the square root to the outside, we would end up with 2 times 2 square root of 5, which would be 4 square root of 5. The optimal number that we could have used was 16 and 5. I highly suggest that whenever you are working the breakdown of a number, you grab the number, set at the very top, and start with 1 and find all the factors. 1 and 80, 2, 40, 3 doesn't work, but 4 does. 4 and 20, 5 and 16. 6 does not work. 7 does not work. 8 and 10. 9 does not work. Notice we're back at 10 on this right-hand side. This gives you a view of every single possible terms that we can use in order to get 80. And from there, you can work your best solution at finding your perfect squares in order to be able to work them. So 4 and 16. Notice 16 would be a better choice because it leaves you with a 5, which is prime and cannot be broken down further. So as we go ahead and start breaking this down, we go ahead and end up with 6 plus or minus 4 square root of 5 over 2. 6 divided by 2 plus or minus 4 square root of 5 divided by 2. 3 plus or minus 2 square root of 5, comma 0 would be our x-intercept. So 3 plus or minus 2 square root of 5, comma 0. Let's take a look at slide 13. In slide 13, we go ahead and review all of our different quadratic equations, quadratic functions, and we take a look to see what it is that we can use within each one of them. Notice, you have the ability to find different answers, the vertex, roots, our y-intercept, our x-intercept with each one of these. But you need to become familiar and be able to work with all of these different functions. Slide 14 goes ahead and reviews the same material that we just finished reviewing in a different way. Notice, it is up to you, whichever method that you prefer to study as far as slide 13 or 14, but they are all referencing the same information and giving you on how to solve these different forms and what would be best to work with. If you have any questions, feel free to ask at any point.